In the previous lab, we have learned about how to install ROS, and we almost completed the installation tutorial, and now we shall start a basic level of tutorials in the ROS. So in the section 2, you have to press just this link, ROS tutorials, and it will take you to this beginner level of tutorials, and there you have to just press this one, installing and configuring your ROS environment. Here the first thing you can do is if you want to know that where your ROS has been installed and is it installed properly or not, then you can copy paste this command, which is in this section, managing your environment. So this is I have opened the terminal where I can copy paste the commands, paste the commands only. I pasted it and then press enter, and here you can see that it shows that the ROS version, the Python version it's using, and the package path we have, which is opt, ROS, noitic, and share. So these are the folders and subfolders on your virtual hard drive where the ROS has been installed. The ROS packages has been installed. And if you want to see the ROS directory where the ROS is actually installed, this is the path: opt, then subfolder ROS, then there is a subfolder noitic, then etc, and ROS. So here the main installation of ROS is located here. Okay, so now we know the location of the ROS. Now the second thing we have to do is we go to step number 3, which is the create a ROS workspace. So for this purpose, we make a separate folder for the ROS where we shall make our new packages or test the other packages. So for that we need a new separate workspace or a folder. So let's see how we can create it. The first thing you have to do is to by default it is catkin is selected. You have to select catkin only, not the other one. If you select the other one, this is for the older versions of the ROS. So you have to only select catkin, and then you have to copy these commands here. So what the first command does is mkdir, it makes a folder. The name of the folder is catkin ws or the catkin workspace, and the subfolder is src. Just paste in your terminal and press enter. Okay, so now there should be a folder in your file. So let's visit the files and see where the ROS and this new folder is located. So this is my virtual hard drive, and you can see here this is the folder we have created, catkin ws or catkin workspace. And when you double click it, and in this there is a subfolder named src. So here we have done using this command, catkin ws and src. And if you want to see where the ROS is located, then you have to maybe public pictures, music, downloads. You have to go to your drive, and here in this drive you have to look for folder named opt. Or let's go to home, desktop. No, it's not located here. Pictures, public. Okay, let's see other locations. Okay, so it seems like it's difficult to find the folder, this OPT folder, but we can always assess using this terminal, and later I shall also see where it is exactly located, so we can see it also. Okay, so for this command we have created this catkin workspace folder, and just minimize this one, and now copy paste the second command into your terminal and press enter. So now you see that we are now in this folder. Okay, now we have entered in this folder. So if you want to see what are the subfolders in this folder, you can just press ls, and you can see here this is the subfolder src. So in catkin workspace folder we have src subfolder. So whenever you want to enter a folder, you have to press cd and the specific path of that folder. Okay, and then you shall be in this folder. And when you want to see what are the other folders, subfolders, or the content of this folder, then you have to just type ls and press enter, and it will show you all the subfolders inside your current folder. Okay, so if now we want to we are in catkin workspace folder. Now we go again to our ROS tutorials and copy this command and paste it in the terminal. Catkin make. So what this command does, it actually it compiles any kind of code in your catkin workspace. It compiles them, it makes them ready so it can be executable. You can see it's now building some libraries, and although there is no code till now, but this is just to make sure that ROS knows that where the folder is located. Okay, here you can see that if you look into your current directory, you should now have a build and devel folder. Okay, now let's see in the catkin workspace. Previously it was only src folder. Now there is a build and devel folders also. And what it says that inside the devel folder you can see that there are now several setup.sh files. Sourcing any of these files will overlay this workspace on top of your environment. To understand more about this, see the general catkin documentation catkin. Before continuing, source your new setup.sh file. Okay, so now when we see that in the devel folder, you see that there are setup.bash files here, and what we need to do is we need to source this file so that your ROS knows that where is your new workspace located. For that you have to copy paste this command here and press enter. Okay, now your ROS knows that where your new workspace is located. To make sure ROS knows the path, you have to type this command, echo ROS package path. When you type it here, you see that so the ROS knows that this package is located at home, Amir, catkin workspace, and then src. And the other path is opt ROS noetic share. This is the original path where the actual ROS is located, and this path is for our newly created workspace folder. Okay, this is how we tell ROS where is our new workspace is. Okay, so now we have completed the workspace, and now let's see some file system tutorials of ROS. Okay, for this tutorial we will inspect a package in ROS tutorial. Please install it using. Okay, you have to copy this command here. You have to paste it in here in your terminal, and here you have to write down your actual distribution, ROS distribution name, which is Noetic. Okay, so remove the distro, and then you have to enter here Noetic, and then press enter. Then you have to give your password. And now installation has been started. Okay. So ROS has actually in the file system of ROS we have packages. Packages are the software organization unit of ROS code. Each package contains libraries, executables, scripts, or other artifacts. So a package is like a folder. In the folder you have some libraries, some executable files, some that like in the Windows we have some executables, and then there are some scripts like your C code or Python code. And then we have manifests like package.xml. A manifest is a description of a package. It serves to define dependencies between packages and to capture meta information about the package like version, maintainer, license, etc. So another type of thing in the package you have is the manifest. So they have always this extension called .xml. So what they are used for, they use to describe your package. For example, your package depends upon what other kinds of packages or what other kind of libraries, and then there will be some in this XML file. There will be a version number and license information written. Then we have file system tools. So the first one is using ROS Pack. So how we can use ROS Pack? ROS Pack allows you to get information about packages. In this tutorial, we are only going to cover the find option, which return the path to the package. So for example, if we want to find any package or any folder in the ROS, how we can do that? We can do using this command, which is ROS Pack find and then the name of your package. For example, my package name is ROS CPP. Okay, and I need to find that where this package is located, which is a path to this package. So how can I do that? I just copy paste this command. So here ROS Pack find and then your package name. ROS CPP is a C++ package. Then enter. So here you can see there is a path to this package. So first you have to go to OPT and then ROS, then Noetic share, and here is your package folder ROS CPP. If you install ROS Kinetic from APT, okay, we are not concerned about this one. Okay, using ROS CD, this is another important tool in ROS. ROS CD is a part of the ROS bash suite. It allows you to change directly to the package or the stack. Okay. So this ROS CD it actually is used to change the path. For example, if you want to enter a package and you want to see what are the subfolders, then you can use this ROS CD. So how you can do that? You type this command ROS CD, and then you have to type the your package name, just simple, and then this will take you, this command will take you inside the package. So let's enter this command ROS CD and ROS CPP. Now see that you are inside this package. So your address is opt ROS noitek share ROS CPP, and here when you press here ls, you see that these are the contents of your ROS CPP. There is a CMake, MSG, and then XML file, and then build file. So one more command is the pwd, which is the present working directory. I assume, or no, sorry, it's let's print the working directory using Unix. Sorry, it's the print working directory, I guess. So let's type here pwd and press enter. So now this is you are inside this ROS CPP folder you are working. But previously, if you remember, we were in our catkin package, the catkin folder. So yeah, this is how you can enter any package in the ROS. Okay, this is again another tool for the ROS, which is the to show the subfolders of any package. And what you have to do, you have to okay, now you are in ROS CPP, and you want to go back to your last or the previous your home folder. You have to press CD and then dot, and it will take you to a step back. And when you press CD and dash, then it will take you to your home position. Okay. So let's copy paste this command here. So now you see that now we have seen the content of this ROS CPP tutorials, and then in this package we have CMake, launch, and XML file. So the next tool in the ROS, we have the tab completion. So what you need to do, you just copy this command or just write it, don't copy, just write it. ROS CD space, then ROS CPP and underscore, then to TU. Then you don't need to type all the spellings, okay? Just type tab button in your on your keyboard, and it will automatically complete the package name. So let's say ROS CPP. If I press tab here, it doesn't work because there are multiple ROS CPP packages. So just specify it and ROS CPP and T. Now press tab again, and it says there are two more you can say packages with the same name. So I more specify TU. Now press tab. Now tutorials. Yeah. So this tab completion is also a tool in your ROS, especially when the package name is long, then you can use it. Okay, well, we try one more thing. We try this ROS CD and TUR, and then press your tab button on your keyboard, and it says turtle. It has automatically completed. And thus press enter. Now say no such package as tag turtle exists. It should be there. However, in this case there are multiple packages that begin with turtle. Try typing tab another time. They should display all the ROS packages that begin with turtle. We'll try a different name. ROS CD turtle sim. Turtle sim. No, sorry. And let's see what are the contents of this package ROS turtle sim. And you can see there are CMake files, XML files, and these files are there. Okay, so for the review, ROS pack is ROS plus package. ROS CD is ROS plus CD. So CD is when you want to enter any package, when you want to open a package. ROS LS, ROS plus LS, which is mean the list of the packages or the files inside your package. Now we quickly move toward our next tutorial, which is create a ROS package. What makes up a catkin package? For a package to be considered a catkin package, it must meet a few requirements. The package must contain a catkin complaint package.xml file. So in a ROS package, there must be a XML file. That package XML file provides meta information about the package. For example, the version, the license, information like this, and its dependencies. The package must contain a CMake list.txt, which uses catkin. If it is a catkin meta package, it must have the relevant boilerplate CMake list.txt file. So this CMake list.txt file, it helps to build the package, to make it executable. So later we shall see that how we can use it. Each package must have its own folder. This means no nested packages nor multiple packages sharing the same directory. So these three things are important. So the first thing is there should be an XML file telling about the information about the package. Then there is a CMake file, which is .txt. It tells about it has information about how to make the package executable. And then we have a folder which contains the code for the package Python code or the C++ code. So let's make a package, and the package name is my package. And where we shall make it? We shall make it in the our catkin workspace, the folder that we have made here. You remember here? This was the catkin ws folder, and here we have src folder, and inside this folder we shall make our new folder, which is called my package. Okay, so let's first exit from this turtle sim. We press cd and this dash 2 times, and we are at home now. We are now in the home location, and from here we enter cd catkin _workspace. So now we are in the catkin workspace folder, and we again enter cd src. So now we are in src folder. So here we sorry, so there was a mistake. This is just an example, this is not a command here. So it says that a package, which is my package, it may looks like a .txt file and then XML file. So this is the simplest package, example of package. But there can be other files, for example a Python code file or a C++ file also. So this makes a package. And I think in the upcoming later in tutorials we shall also learn how to make a package, but I think at this level it's too early. So here this is a quick review about what are the packages in your ROS workspace folder. Then we have src. Src is a source space. If you see here in your home, this is your workspace, catkin workspace, and this is source space, your folder. Okay, and then we have cmake list.txt. It's a top level cmake file provided by catkin. Okay, then we have cmake list.txt. This is file for package 1, package 2. So in a package there can be multiple sub packages. In a folder there can be multiple subfolders, and each subfolder or each package must have its own XML and TXT file. Okay, and it should be also a separate folder for each package. Okay, creating a catkin package. This tutorial will demonstrate how to use the catkin create package script to create a new catkin package and what you can do with it after it has been created. So for first, change to the source space directory of the catkin workspace you created in the creating a workspace for catkin tutorial. You should have created this in the creating a workspace tutorial. Okay, so this command, enter this command, copy paste, but we are already in the source folder, so I just to go back first to home. So now we are one folder back. If you press this again and enter, now we are at home. So when you want to go to catkin source folder, you have to paste this command from here and press enter, and now you are in your source folder of catkin workspace. Now use catkin create package script to create a new package called beginner tutorials, which depends upon std standard messages, ROS CPP, and ROS Python. So here what we do, we try to make a new package whose name is beginner tutorials. Okay, so using this command, catkin create package, the name of the package, and this is the dependencies. Just copy and paste in your terminal and press enter. So now it says that successfully created a folder or a package in your src folder. So we go and we confirm it here. So see that this was our home, this is Catkin Workspace, and this is our source folder, and here we have created a new folder or a package named beginner tutorials, and inside it you can see there is, again, you have txt and xml file about this package. So let's see what else we can do with it. This will create a beginner tutorials folder which contains package.xml and cmake list.txt, which have been partially filled out with the information you gave catkin create package. So this is a command to create packages in ROS. Catkin create package requires that you give it a package name and optionally a list of dependencies on which that package depends. So what is a dependencies? It means that if your package is using a C++, so it means that it also uses a C++ package in ROS. So it means that your package is dependent upon other packages in ROS. This is an example. Do not try to run this, okay? So catkin create package, package name, dependency 1, 2, 3, and so on. Catkin create package also has more advanced functionalities, but I think for beginner level it's okay. Step number 4, building a Catkin workspace and sourcing the setup file. So now we need to build the packages in the Catkin workspace. So you remember we just made a package name beginner tutorials, and now we have to build it. We have to build this package. Building a package is like when you, for example, in C++, you make your code. You first write down your code, and then you make it executable. Okay. So in here also it's same thing going on. When you build a package, so it means you are now making it executable. So you have to type these commands. So from here I go to the home folder, cd / enter. Now I'm in the home folder, and here I type catkin cd catkin workspace, and now I'm in a catkin workspace. And here, when you are in your catkin workspace, then you can always make it. Enter this command, it will build your catkin workspace. Enter, and now it started to build your workspace, and all the packages and any C++ files or Python files, they will be converted into executable files. After the workspace has been built, it has created a similar structure in the devel subfolder as you usually find under opt ROS. Okay. To add the workspace to your ROS environment, you need to source the generated setup file. Okay, now you have so when you enter this catkin make, so it has now created new executables, and and also it has created a similar structure in this devel subfolder to find under. Okay, so now there are some new files created. Okay, and now you have to tell ROS about these new files, the created new files. And how you can do that? You can copy paste this command and press enter. So now ROS knows the newly created files. Okay, step number 5, package dependencies. First order dependencies. When using catkin create package earlier, a few package dependencies were provided. These first order dependencies can now be reviewed with the ROSPack tool. Okay, so ROSPack dependency 1, beginner level tutorials. So just copy paste this command and press enter. So you see that the package we have created, beginner tutorials. If you want to see that what is the first order dependencies, so this package depends upon ROS CPP, which is ROS C++. This package also depends upon ROS PY, which is ROS Python, and then std messages, standard messages. So our package has this first order dependencies. So to run this, to execute this package, we also need these 3 packages installed in our ROS. As you can see, ROSPack lists the same dependencies that were used in arguments when running catkin create package. These dependencies for a package are stored in the package.xml file. So when you open you can also view these dependencies in your XML file. For example, if you go there in your package, beginner tutorials, and you open this one, package.xml, and here you shall see that there must be written here these dependencies. See that ROS CPP, ROS Python, and standard std messages. So these dependencies are written here also. So we close it, and now these were the direct dependencies. Now we shall see in the next step the indirect dependencies. In many cases, dependency will also have its own dependencies. For instance, ROS Python has other dependencies. So when you want to see that, okay, for example, this beginner tutorials package, it depends upon these 3 other packages, ROS CPP, ROS Python, and now you need this package, for example, let's say ROS Python, and for that ROS Python also may need further some more packages or some more folders to work properly. So for that we again type this command, ROSPack dependency number 1 and then ROS Python, and then it shows you this package ROS Python. This dependency further depends upon these different types of other dependencies. So for this you also need to have all these things present in your ROS, okay, and then you can finally work with your beginner tutorials. A package can have quite a few indirect dependencies. Luckily, ROSPack can recursively determine all nested dependencies. Okay, so when you type here ROSPack depends, not this time, not the 1 or anything, just depends, and then paste here and press enter, then you see that now it's showing all the dependencies. When you type here 1 depends 1, then it only shows the first level, okay, but when you write here depends, then it shows all the other packages and other you can say code that is required to execute your ROS package. Now step 6 is the customizing your package. This part of the tutorial will look at each file generated by catkin create package and describe line by line each component of those files and how you can customize them for your package. Customizing the package.xml. The generated package.xml should be in your new package. Now let's go through the new package.xml and touch up any elements that need your attention. Okay, so first we customize our package.xml file. So step number 6.1, the generated package.xml should be in your new package. Now let's go through the new package.xml and touch up any elements that need your attention. So if we go to our package where we have created it, and here you see package.xml file. But by convention, the first sentence should be short, while single sentence, then it might need to be broken up. So it says that this is already our description of your package. Okay, 6.1.2 comes the maintainer tag, line number 7 to 10. So you see an important Okay, so this is a sign of a comment. If this sign is there, it means that this is a comment. And without this sign, this is a normal code we have. So like we do in MATLAB, we have some code and then there are some comments. So here also in XML file, we have same thing, comments and also the actual code we have. So here if you can do any changes if you want, and the changes are not recommended here, I think. This is a required and important tag for the XML. At least one maintainer is required. Okay. Okay, let's quickly move to the license tags. Next is the license tag, which is also required. So line number 12 to 15, there is information about the license of this package. So BSD, MIT, Boost software license. So they have their own versions of license, and we shall not go in deep here. You should choose a license and fill it in here. Some common open source licenses are BSD, MIT, Boost software license, and there are some other versions also. For this tutorial, we shall use a BSD license because the rest of the core ROS components use it already. So the most commonly used license we have is the BSD license, and we shall also use here. Line number 8, here's written here. Okay, no, not line number 8. It's actually, where is the license file? Yeah, here. This is the license area here, and you see that they all were comments here. And here, line number 15, this was actually your code for XML code. So Let's see if we can change it here. Okay, here we have this, and after that we have to write down the type of license we have. So just copy paste it from there. License, BSD license. Okay, copy and paste it here after the to do line number 17. Okay, 1.4 dependencies tags. The next set of the tags describe the dependencies of your package. The dependencies are split into build dependencies, build tool dependencies, and then we have execution dependencies, test dependencies, catkin dependencies. Since we passed to 41, they all describe the dependencies. Okay, so they have Python and standard messages 39, 40, and 41. Okay, I think we have a mismatch of line number, but we have at least these kind of dependencies here. For example, starting from here, this is a build tool dependency. Build tool is a catkin. So this means that this package will be built by catkin, using catkin command. So where it is written here, build tool catkin, yeah, this is here. And before that, they're all comments here. These are all comments. Okay, so this is a build tool dependency. Then we have build dependency, which is ROS CPP, ROS Python, and std messages. Okay, we have now this. All of our listed dependencies have been added as a build depend for us. In addition to the default build tool depend on catkin, in this case we want all of our specified dependencies to be available at build and runtime. So we shall add a executable dependency tag for each of them as well. Okay, so here you see, once this was build for build dependencies, and then we have build export dependency, ROS CPP, ROS, so again same all of, and then we have execution dependency also. So for building the code and for execution, we need these other packages or other dependencies to run, to compile our package or to build our package. Now 6.1.5 final package.xml. As you can see, the final package.xml without comments and unused tags is much more concise. So without comments, it's not that long. So we only have here the version, then we have format, and then the name of our package, we have the details and the version, and then you have to describe here what this package do, and then the person who maintain this package, who develop and maintain. And then we have license here, BSD license we have given. I think he has removed this to do license. I think to do license he has removed, and there is a BSD license. So after maintainer, this was a maintainer, this was the last command we have. So we have to remove this one here. We have to comment this one. So this is how we can comment it. And then we have so now this is commented, and this is our actual command here, bst license. And then we have the website, and then build tool dependency, which is catkin, and then build dependency. During building this code, we need these kind of dependencies, and then during the execution we need also these kind of. I've noticed that the build dependency they are only 3 times, so let's see how many times we have here. So here we have build export dependency also, these 3 commands which are extra, I think, but let it be there, and if later we have some problem, then we can correct them also. Okay, so this was our XML package, and now we move quickly to the 6.2, customizing the CMake list.txt. We close this one. We'll first save it and then close this one, XML file. And now we shall see the CMake txt. Now that package XML, which contains meta information, has been tailored to your package, you are ready to move on in the tutorials. The CMake list.txt file created by catkin create package will be covered in the later tutorials about building ROS code. So this one we shall cover later. So let's now move to build our ROS package. Building a ROS package. This tutorial covers the tool chain to build a package. Okay, building packages. As long as all of the system dependencies of your package are installed, we can now build your own package. So we need dependencies, and then we need to build the package. If you install ROS using apt or some other package manager, you should already have all of your dependencies. Okay, before continuing, remember to source your environment setup file if you have not already. On Ubuntu, it would be something like this: source opt ROS your ROS distribution setup.bash, and I think we have already did that already. Okay, using catkin make. Catkin make is a command line tool which adds some convenience to the standard catkin workflow. You can imagine that catkin make combines the calls and CMake and make in the standard CMake workflow usage. In a catkin workspace, catkin make, and we have already tried this command in our workspace, and we already have built our workspace. So whenever you want to again you do some changes in your package here, for example, in this package you add some Python code or C++ code, and then you want to you have to catkin make it. You have to build it using command catkin make, and then after that you have to tell the ROS about the new setup.bash files created in devel folder. Here, if you see here, beginner level tutorials, and then here we have okay, here, sorry, devel here. So this here, setup.bash, this one file, you have to source it every time you change your package. You have to source this file to this setup.bash. Okay. For people who are unfamiliar with the standard CMake workflow, it breaks down as follows. Usually if you're familiar with programming using C++ or C, so it has some commands like CMake or make that is used to build your code. When you write your code in C++, then you use some command to make executable and build your code. So you use something like CMake or make, okay? And this process is run for each CMake project. In contrast, catkin project can be built together in workspaces. Building 0 to many catkin packages in a workspace follows this workflow. So instead of using CMake and make for each of the package, what we do here, for simplicity, we directly use catkin make, okay? Then we may use also catkin make install, but normally we only use catkin make, and this will build all the packages available in our workspace here. So we go to this catkin workspace, and when we type this command catkin make, so it will build all the packages available in this src folder. Okay, the above commands will build any catkin project found in the src folder. This follows the recommendation set by REP 128. If your source code is in a different place, say my src, then you would call catkin make like this. Note, if you run the below commands, it will not work as the directory my src does not exist. Okay, so if you want to, specifically build a folder, then you have to type something like this, catkin make, and then -- source, and then your folder name here. Okay, option, you can also use this command also. Okay, build your package. 1.2 step 1.2 says that if you are using this page to build your own code, please also take a look at the later tutorials, since you may need to modify cmake list.txt. Yes, we haven't studied till yet how to modify this .txt file. You should already have a catkin workspace and a new catkin package called beginner tutorials from the previous tutorial, creating a package. Go into the catkin workspace if you are not already there and look in the src folder. Okay, we have just type this command here. I think we have already done this one here. We have completed this catkin make already, but since we have made some changes in our XML file, so once again we build our code. Okay, so let's copy this command here. So now we are in the catkin work. So let's now here copy paste this command catkin make and press enter. So now it will build all the packages inside our workspace. We have only one package, and its name is beginner tutorials. So see here, it has been built already. And now if you see that, you should see a lot of output from CMake and then make, which should be similar to something like this. Yes, we have something like this already. So what catkin make is, actually what I found is that it's a combination of CMake and make, something similar to like this. Note that catkin make first displays what path it is using for each of the spaces. The spaces are described in the REP 128 and by documentation about catkin workspaces on the wiki. The important thing is to notice is that because of these default values, several folders have been created in your catkin workspace. Take a look with ls. So just type your ls, and you see there's a build folder. This was already there. The build folder is the default location of your build space and is where CMake and make are called to configure the build your packages. So yes, when you type catkin make, so actually it calls CMake and make both using the help of this build folder. The devel folder is a default location of the devel space, which is where your executables and libraries go before you install your package. So okay, so devel folder contains your executables and libraries. Now that you have built your ROS package, let's talk more about ROS nodes. So till here, we have already seen that what are the ROS packages, what are its components, where the ROS is located. Did we find that? No, we didn't. We were in the home folder and we wanted to see where the ROS is located, and so it should be here in your VirtualBox drive or maybe other locations. Yeah, in your other locations, and then you have to press your computer, which is your virtual computer, actually virtual hard drive. And here if you see that the folder OPT, this one here, OPT, and here is the ROS Noetic. So this is our ROS, and these are all the subfolders of our ROS. And then we installed ROS, and then we manually today we created a catkin workspace, and then we saw that okay, what are the subfolders of the workspace and how we can build it. And then we saw that how we can also modify the XML file. And in the build file, you see that there are many subfolders, and these are used by your make file and also your CMake file, to CMake commands to build your package. And then there is a devel folder, and in this one you have your setup.bash file, which is important, and then there is libraries, any code you have mentioned. This executable will be here inside this folder. And then there is a src folder, and in src folder there can be multiple packages. And yeah, so today also we learned that how we can build our workspace and how we can build the package we have inside in our workspace. Okay, so here what we do here is this is about understanding ROS nodes. This is